Hello, I'm Dr. Steve Warner, and today I would like to teach you a nice method for multiplying polynomials. Most students are familiar with the mnemonic FOIL to help them multiply two binomials together. Binomials are polynomials with two terms. For example, let's look at this product, x plus 1 times x minus 2. The F in FOIL stands for first. X times x is x squared. O is for outer. We multiply x times negative 2 to get negative 2x. I is for inner. 1 times x is 1x, or just x. And L stands for last. 1 times negative 2 is negative 2. We can then add negative 2x and x to get x squared minus x minus 2. I don't particularly like teaching this method of foiling for multiplying binomials for the following reasons. First of all, this method only works for binomials. It does not extend to polynomials with more than two terms. Secondly, it requires learning something new. FOIL is a genuinely new method that is not an extension of the multiplication that students already know how to perform. Third, even though most students know how to FOIL, they don't really understand why it works. And lastly, perhaps not as important, is from a theoretical point of view, FOIL is actually not as efficient as FIOL, F-I-O-L, which would be to do the inner before the outer. Before I get to the method I want to teach for multiplying polynomials, let's just do a very quick review of multiplication of numbers. So let's multiply the numbers 12 and 32 together using a method that most students already know. So we start by multiplying 2 times 2 to get 4, and then 2 times 1 to get 2. We leave a placeholder, or if you'd like, you could put a 0. And then we do 3 times 2 is 6, and 3 times 1 is 3. And then finally, we add, going from right to left. 4 plus 0 is 4, 2 plus 6 is 8, and bring down the 3 to get the answer of 384. I'd like to now go back to the first example of multiplying those two binomials, but this time I just want to simulate the method I just used for multiplying two numbers. So let's start by doing negative 2 times 1 to get negative 2, and then negative 2 times x to get negative 2x. If you want, you could put a placeholder of 0 here. And then let's do x times 1 to get positive x, and then x times x to get x squared. And finally, we add, going from right to left. Negative 2 plus 0 is negative 2. Negative 2x plus x is negative x. And bring down the x squared. And notice we get the same answer as before. Let's now go to a harder example. So this time I'm going to multiply two trinomials together. These are polynomials with 3 terms each. Foiling would not work in this case, but the method that I just showed you will. 3 times negative 1 is negative 3. 3 times 2x is 6x. 3 times x squared is 3x squared. Let's put in a 0 placeholder. Negative x times negative 1 is positive x. Negative x times 2x is negative 2x squared. Negative x times x squared is negative x cubed. And now let's put in 2 placeholders. 2x squared times negative 1 is negative 2x squared. 2x squared times 2x is 4x cubed. Plus. And 2x squared times x squared is 2x to the 4th. And now, as before, we add negative 3 plus 7x minus x squared plus 3x cubed and 2x to the fourth. And we have our final answer of 2x to the fourth plus 3x cubed minus x squared plus 7x minus 3. Here's a more difficult example for you to try at home. Just to start you off, negative 4 times negative 1 is positive 4. Negative 4 times x is negative 4x. Negative 4 times negative x squared is 4x squared. And I'm going to leave the rest of this one up to you. Let's try one more example that's in the form of a standardized test question. For all x, 5x minus 4 squared is equal to which of these? First, remember, to square something means to multiply it by itself. So we're multiplying 5x minus 4 times 5x minus 4. Let's go ahead and use the method that we just learned. Negative 4 times negative 4 is positive 16. Negative 4 times 5x is negative 20x. Okay, let's put a placeholder in and move over. 5x times negative 4 is again negative 20x. And 5x times 5x is 25x squared. And now we add 16, negative 40x, and 25x squared. And that is choice E.